In a world brimming with complexity, few creatures embody harmony like the honeybee. With tireless precision, she dances from bloom to bloom, each motion guided by millennia upon millennia of instinct, each act in service to the whole. And then there are the beekeepers, watchful stewards of this ancient symbiosis. Part agri-scientist, part poet, they move along their hives with the efficiency of Mo, Larry, and Curly, tending to the bees' needs as best they can comprehend, and with the infrequency of a waterfall in the Sahara, sometimes running off, flapping and flailing like a penguin on a hot sidewalk. This is their journey.
Welcome to Bee Love Beekeeping, presented by our good friends over at Man Lake. Today's show features the conclusion of our discussion with the amazing Dr. Tom Seeley. We'll learn about everything from the Tremble Dance to drone congregation areas, bees' various jobs in the hive, even the proper pronunciation of the word, and I better just spell it, Propolis, and a whole ton more. We might even find out if he has a wild and crazy story to share. First, a new feature that we're calling Invention Mentions, where we test out innovative products in the beekeeping world. Some new, some improved, or some that are just used in new ways. Today I'm going to try out for myself Man Lake's new premium hive stand. Take a look. Hey, the product we're testing out today is Man Lake's new hive stand that has adjustable legs, and this thing is heavy duty. Now, let me show you what it does. First of all, super easy to put together. When it's shipped to you, all you have to do is put in 1, 2, 4, 6, 8 bolts, really easy. There's not even a nut on the other side. And if you don't have a big toolbox, they even sent this wrench. So you put those bolts in, you snug them up a little bit, you're good to go. This is powder coated, so it's not going to rust on you. Now, here's the cool feature. We are on a little bit of a hill right here. It slopes from where I am down that way. So we can take the legs on the downhill side. I've already adjusted them a little, but we can just make them longer like that. Now, if I was setting this up for long term, I'd put a level on it right now. See how it's sitting? But it feels fairly level. It feels super sturdy. I'm going to test it out. I've got a hive right here, a box with no bees in it. I didn't want something too heavy for this demonstration. Let's get it on here. Easy peasy. Okay, I like it, but that's one empty deep box. So the question is, how strong is it? Let's say you have 2 brood boxes. You've got a honey super, another one, a third, a fourth, a fifth, a sixth, a seventh. So you've got, I don't know, a few 100 pounds on here. Let's see if it can take the weight. All right, I don't want to kill myself. Oh yeah. Wow. That thing is seriously strong. If you have something that you'd like to see featured, shoot me an email, eric@beelovebeekeeping.com. Now, let's head back to Maine and our discussion with Dr. Tom Seeley. Tell me how beekeeping has changed over the years, since you've been doing this for 56 years. And I don't mean to pronounce it like that as, wow, you must be 100 years old. but that's a long time. And people I've talked to, old timers, are like, it used to be so easy.
Yeah, it used to be that American foul brood was common, and that New York State had a regular inspection. You're required to get your colonies inspected every year. I haven't seen American foul brood in decades. Maybe that's unusual, but I think American foul brood has gone way down in its incidence. Um, Chalk brood was, when that first came in, that used to be a real problem. I don't know what the experience of others is, but I haven't seen it in a long time. And I think that's a good example of how natural selection worked. There was very strong selection in favor of colonies that could handle chalk brood because we didn't really have any treatment for it. Another key feature of this treatment-free beekeeping is letting colonies swarm. That brood break is hugely valuable. And I think for Kirk Webster in Vermont, he doesn't have his colonies swarming, but he's making splits of them all the time because he sells a lot of 3-frame or 5-frame nukes. He rears his own queens and he splits his colonies, so there's brood breaks.
Oh, we've talked a little bit about swarming and swarm behavior, and this is something that you are absolutely an expert on. And I loved reading about some of your experiments on a island. What were you, 7 miles off the Atlantic coast?
Yep, little treeless 100-acre island, no natural nest sites.
And I assume that the idea of that was you're far enough away that you're not going to get bees out there that aren't part of your experiment, and bees in your experiment can't just leave. And yeah, without trees, when you're learning swarming behavior, you were giving them places to swarm too, and those were their only options. What are some of the highlights of things that you learned?
Well, one of the first things I wanted to do was figure out. I knew that bees avoid nest cavities that are too small. So in general, when I began my work on this island, and it was just as you said, it was an island where I controlled the options of the bees, the home site options. I would set up, instead of an observation hive, I had set up an observation nest box. So I could see what the nest site scouts do when they go inside a potential home site. And I knew that the bees were very careful to avoid a nest cavity that was too small. So I knew, well, how do they measure the volume of one of these cavities? So one of the experiments I did on this island was I built a nest box that was a cylinder that I could rotate. Because I could rotate the walls, I could shorten the amount of walking a nest site scout had to do to walk around to trip around inside the cavity, or I could make it longer. The cylindrical nest box that they walked into, which was mounted on a turntable thing so it could be rotated smoothly, it was right on the threshold of being big enough. So if I made the bees walk more, if walking was how they measured it, then if I made it walk more, then they should think it was good, really good. If I made it so they had to walk less than they normally had to walk to get around from where the light is, where the entrance is, back to the entrance place, then they should think it's too small. And that's in fact what happened. If I made a nest site scout not have to walk much to circumnavigate the cylinder, she didn't like it. She wouldn't go back and dance. If I made her walk more, a longer distance to walk to circumnavigate this cavity, she would go back and she danced. She thought it was the right size, was big enough. So that was one of the features of working on this island. There was a downside too, though, Eric. There were 2 lobster fishermen. They had their houses on this island. And my bees they were desperate. So one of my early swarms, I think it was my first swarm, they found the chimney of one of the lobster fishermen. And they liked that. They liked that place a lot. And I had been told to never go over to Rodney Sullivan's place because he didn't like people poking around his house. But I had to and introduce myself. And the fierce Rodney Sullivan, once he learned that I knew about bees and could get rid of them out of his chimney, he was a very accommodating gentleman. So it just involved getting a ladder up on the side of his house and sealing off his chimney, putting some screen over his chimney. That's the kind of stuff on the island. The island became a laboratory because I controlled the options of what the nest site scouts could look at.
Any other interesting tidbits that you learned that beekeepers can use?
Oh, you mean from the island or in general?
Yeah, from the island. I mean, you learned about the size of a box that swarms liked, right?
Yeah, and how the main thing I learned on the island and with respect to that was how they assessed the volume of the box. I already knew that they were avoiding really small cavities and really large cavities. They had a size around one deep hive body that was the sweet spot for them. A lot of the other things we learned on the island, and here's one that's again useful. We studied a lot how the swarms organize their movement once they finish their decision making. We could take a swarm out to the island. Again, we could watch what the scouts are doing at a prospective home site. And we could also watch what they're doing, of course, back at the swarm. One of the things that we studied really closely was once the nest site scouts have finished making a choice, found a site that's become popular enough, how do they then tell all of the other bees in the swarm cluster to get ready to take flight? And so we learned that they make a special sound. It's called piping. It sounds like we learned that that's the warm-up signal, and then we learned that they have another signal once the nest site scouts have gotten all of the other bees in the swarm cluster warm enough. They have a takeoff signal. It's called the buzz run, where a bee runs across the surface and burrows into the swarm cluster while buzzing her wings. So we learned a lot about how they organize the takeoff of the swarm. And we also studied how they steer the swarm to its new home site. Again, because we had control of all these things. We knew we could set up a swarm on one side of the island. We could put up the nest box down a road on the island and follow the movement of the swarm during its flight and video record it. The video recording was very tricky because you have to have the swarm fly right over your video camera, so it's looking straight up. And I worked with an engineer from Ohio State who was a whiz at this kind of thing. It became very clear that how the scout bees steer a swarm. They do it by shooting through the top of the swarm in the direction that they want the swarm to move. And when a scout bee shoots through it, she gets to the front of the swarm. Then she flies back slowly and underneath the swarm until she's in the back again, and then she'll shoot through it again. So they keep pointing the way. So those are some of the things, how the swarms move. So much of the biology of swarms is hard to study unless you know where the swarm is. You can watch the swarm and you know where it's going. And then we learned how they organize the move in to their new home site.
And when these scout bees go out and they come back and they're somehow communicating with the swarm, and they're doing it by dancing and pointing, and you can explain it much more scientifically than I can. But I don't get how a collective decision is made. I mean, we use human terms, and you even used a human term, democracy and voting. And but is it really like voting, or is it more like convincing, or is it, I don't know. How does it really happen?
Let me begin to answer that, Eric, by saying why I use the word democracy. I use that term because it is a collective decision-making process. There's no one individual that gets to, there's nobody that's the supreme decider in this thing. It's dispersed among all the nest site scouts.
Including the queen, by the way. She's not the supreme decider.
She's not the supreme leader. She's passive in the decision-making of the new home site. You might say it's a form of democracy where it's like, in our own election system, we vote, but it ultimately comes down to the electoral college that actually makes the votes that get counted.
So in other words, you don't have 20,000 bees in a swarm all raising their left wing and saying, yeah, we want to go that way. You have an electoral college of all these scouts that are saying, hey, together we have found the best spot. Let's go, everybody.
Yeah, it's about 5% of the swarm. This are the nest site scouts. They're the oldest bees, elderly bees in the swarm. And they do have a real debate on the swarm because different bees will come back from different sites. The way the best site wins in this competition is that the nest site scouts adjust how long a waggle dance they perform and how many dance circuits they will perform in relation to the goodness of their site. The better, if a bee comes back from a humdinger of a nest site, she might do 200 dance circuits. If she comes back from one that's okay but not great, she might do 20. And if it's a poor site, she won't do any. Different strength of the advertising of the different sites means that the best site gets the most additional scout bees recruited to it. This decision-making process goes on with this differential buildup of nest site scouts here versus there. But whichever site first gains what I call a quorum of nest site scouts, and I don't know quite how the bees sense a quorum, but it means there's enough bees going to that site. Enough bees are encountered at that site. That tells the nest site scouts who are having these high encounter rates with fellow nest site scouts at a site. That tells those bees our site has attracted enough popularity that we consider it the winner. And then those bees, those nest site scouts, come back to the swarm. They just shut down the debate by switching from doing waggle dances to doing these piping signals, which basically tells the other bees, we figured this out. Let's get ready to take off. Once everybody's launched into the air, those nest site scouts point the way, steer the other bees by pointing the way to fly to the new home site, the chosen site.
It's absolutely amazing. It just is mind-boggling.
I agree. This is a complexity of behavior by insects that is absolutely astonishing. And I think of all of the different behaviors that worker honeybees do, I think these nest site scouts are doing the most complicated task, performing the most complex task. Finding the sites, differentially recruiting to the site, sensing whether the site is a winner or not. If it is the winner, then going back and moving the process from the decision-making stage to taking the action to make the flight to the new home site, and then guiding the flight, and then marking the site when the swarm cloud gets there by releasing the assembly pheromone. Yeah, it is breathtaking. And that is why I wrote a whole book on this subject. You might think, how can you write a whole book on swarming? Well, you can, because that decision-making and that whole collective decision-making process is just so utterly amazing.
If you're a beekeeper like me, we're getting into that favorite time of year, honey harvest. But it can be a lot of work. That's where Man Lake comes in. They have everything you need to make the job easier, cleaner, and more efficient. Removal aids, refractometers, uncapping tools, extractors, tanks, wax melters, even the jars and labels. Plus, they have free shipping on glass containers. Whether you're a hobbyist with 2 hives or a full-blown commercial operation, Man Lake has it all. And don't forget your discount code, MLBLove10. It's in the show notes for $10 off your first $100 purchase.
There's no other animal on the planet other than honeybees that have this where anybody's found anything like this ability to perform collective decision making. We are it. None of the ants, none of the primates, none of the birds. I mean, there are many social birds. Many of the ants are all social. It's just humans. It's humans and honeybees that can do this kind of thing, and that's pretty cool. I think that's really cool.
It is really cool. Your book, Piping Hot Bees, you talk about 20 mysteries of bee behavior solved. We don't have time to go into all 20. You want to pick a favorite, one of those to talk about?
That's like asking which is your favorite child.
You mean you don't have a favorite? I tell each of my kids they're the favorite.
Okay, well, let me collect my thoughts a little bit about that. What I'm thinking, the way I'm going to answer your question, Eric, is I might emphasize one that is a behavior that is not much discussed in any of the beekeeping books. Well, there's several chapters in there devoted to this house hunting process. That's fun. I'm proud of the first chapter because it was the very first scientific study I did. It was how the bees are sensitive to the carbon dioxide level inside their nest, and they will ventilate the nest carefully if the CO2 level gets too high. One of those jumps out as the chapter about resin work. That's something that is pretty obscure when you're doing your beekeeping because it's only a small number of bees, but there are bees that are dedicated to going out and collecting resin, and it's really cool how they organize their work. I admire those resin collectors because they're special. There aren't very many of them, but they do a very important task of getting that antiseptic material into the nest.
And we're talking about propolis now.
Yeah, that's right. I call it resin, but when the bees mix it with beeswax, then it becomes propolis. Yeah.
Okay. And did I pronounce that correctly? Because I've heard it pronounced three different ways. Propolis, propolis.
I think you have it's one if you looked up in the dictionary, but you'd say that you'd probably find both ways are valid. I say pro because pro means in front. Polis means city, so it's in front of the city. That's a very old name. It goes back to the Greeks, I think. Propolis.
Okay. Go ahead and talk about the resin collectors.
Well, the resin collectors are really special. They have to find these resin sources, which are usually coniferous trees, and they're not marked the way nectar and pollen sources are, with bright colors and bright smells. They may orient to the resiny smell, but somehow they find these sources and then they have to pack it into their pollen baskets on their hind legs. And then they come into the nest and they can't offload it themselves. Whereas all of the nectar collectors and the pollen collectors and the water collectors, they usually unload their materials in the bottom of the nest. That's where those materials are needed. The propolis bees, they go up to wherever the propolis work is being done, and it's often near the top of the nest. And then they stand around until one of the propolis handlers chews off the propolis off of their body. So they have to be pretty patient. It's kind of, you might think of it as somewhat nasty work because you're dealing with this gooey stuff. And then you have to be patient. You have to go to part of the nest that's unusual, wherever the propolis work is being done. And so I admire those little bees. Once I was following one of these resin collectors or propolis collectors. It seemed like she got fed up with not getting unloaded for like an hour. And so she started to get the resin off her hind legs and stick it on the gooey surface where it needed to be used. So that's a kind of little observation that I think is very endearing and also very revealing about the behavioral flexibility of a worker honeybee. They have jobs and they focus on one thing at a time, but sometimes they have to show some enterprising, some ingenuity in completing their job, their work.
Do those jobs change a lot during their lifetime? I know most bees start off as nurse bees and then they move on to something else, but are you going to have a resin collector the next day be a guard bee and the next day be something else?
I don't have a firm answer on that, Eric, but what I can say is I think once you're a resin collector, you're a resin collector. And I know the bees that are water collectors, they tend to also be specialists. These are forager age bees. And I think maybe the logic there, why they've organized it this way, is that resin is a material, they don't need a lot of it, but they need kind of a trickle of it to get the nest all coated in the right places and snugged up, sealed up. I think that's part of the logic of why if you get working on collecting resin, you stay a resin collector. With respect to water, again, in our studies, it looked like the water collectors are specialists. And I think, again, it's because when there's a need for water, you really have to have bees that are ready to dive in and start the water collection, lest the nests overheat. Those two are a little different. That's my sense of the situation for those two materials, resin and water.
You're the expert on behavior, and I'm curious about all of it. I can't help it. I just realized I'm trying to come up with something to stump you. So
Okay.
here's another one.
Shouldn't be too hard.
How do they decide who does what? And so that they have just the right amount of water collectors and just the right amount of resin collectors. And we don't need 5,000 guard bees. We need a handful of guard bees. Is there just something innate in them that says, oh, we need more guard bees, I'm going to do that now? Or do you think there is actually some sort of collective decision making on this?
That's a question that I don't think anybody has a good answer to. What I can say is that there's a lot of work, not done by me, but by a gentleman named Rob Page and Gene Robinson, and they find workers that are in different patrilines, that is to say, that have different fathers. And you may know that a queen bee tends to mate with 10 to 20 different males. So there's a lot of genetic variation among the worker bees. Rob Page and Gene Robinson find that the bees that are involved in water collecting are from some patrilines. The resin collectors primarily come from some other patrilines. So some of it is genetics. But some of it may also be experience. If you grow up in a hot hive, that might predispose you to be a water collector, something like that. Or a hive that's getting into the fall, and that's when they start to really seal up their nest. If you're born in the fall, maybe that some way that timing and the need for the resin somehow gets into the brain of a worker bee and steers her to take up that task. These are just speculations, of course.
So, based on that speculation, I'm going to further speculate. Can we speculate that a queen bee is choosing drones to mate with based on, well, I need genetics of a couple of water collectors, and I need genetics of a couple of resin collectors, and I need these other genetics? Am I going way too far now?
Yeah, I'd say, Eric, there's no evidence that, especially with respect to the characteristics of the offspring of a male. Probably most beekeepers have never had the very special experience of going to a drone congregation area or a mating area and seeing what goes on up there. The queen comes in, and a bunch of males, there's a comet of males, maybe 50 or 100, that chase after the queen. One grabs her, they mate, and then she flies on, circles around, comes back, mates again. It seems very clear that she has no selection process, no ability to assess the different drones with their behaviors, quality of their offspring, or anything like that. It's just bang, 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 bang.
So much more random.
And we do know this is probably why the honeybees are, well, you probably know this, they're remarkable for their multiple mating. There aren't many insects that mate where the female will mate with 10 to 20 different males and then mix up the sperm to get a blend of offspring. But honeybees do that.
And only one time in their life, and then be done.
Yeah, that's right.
It's incredible.
It may be that a queen might go out on multiple flights, and if she doesn't get, I don't know, if the weather is bad, she has to turn around, she might make another flight. But yeah, it is a remarkable sight. Once I was lying on the grass underneath the drone congregation area. It's in a little valley on the Cornell campus, and a queen crashed on the ground. Somehow she just crashed on the ground. And I ran over and grabbed her. And I was a beginning beekeeper. And I thought, oh boy, now I got a queen. I can make a split and make a new colony. And then I realized, no, if I don't let this queen fly home, there's going to be a queenless colony. So I let her go. It is amazing to see the frenzy of drones chasing a queen. And sometimes.
How would one find a drone congregation area? I've never seen one.
Yeah, I think the only way that people have found them is to walk around with a helium or hydrogen balloon on the end of a fishing line or fishing pole, and with a queen in a little queen cage. And they're fairly abundant. They're not really rare, at least in hilly country. I think it's just hit and miss. It's just poking around.
Did you say a queen in a cage on a on a helium balloon and a fishing pole?
Yeah, the fishing pole is so you can raise and lower your helium balloon, and you just have the queen hanging down below the helium balloon. It's remarkable, Eric, just how sharp the boundaries are of these drone congregation areas. They're maybe about 100 yards in diameter, but when you get to the edge, the drones just stop coming. I don't know what it is. It's a great mystery. What's going on there? And it's fun to lie beneath one and see the queen come in a comet form.
All right. I have so much appreciated all of your time today. We're going to wind down here. I did forewarn you of one thing, and that is that I wanted to hear some kind of a wild and crazy beekeeping story from Dr. Seeley. And I loved your comeback. You want to tell everybody what you said?
My memory's not very good, Eric. What did I say?
It was something like, I'm a scientist. I control things. There shouldn't be anything wild and crazy.
Oh, that's it. Oh, yeah, that's right. Yeah, that is the nature of my work with the bees. It's usually trying to set something up so I can get the bees to give me an answer.
But also personally, you're a beekeeper and you love bees. So tell us something fun.
Well, one of the things that I really enjoy is extracting honey. And I remember doing that with my daughters when they were little, and they were just so, well, fascinated that you could see they're used to jars of honey, but here there's an extractor and there's a gate, and you open that up, and then just this gush of honey that comes out. I think that's not about bee biology; that's about beekeeping, and I always thought that was pretty thrilling, pretty sweet.
It's definitely part of the joy is
Yeah,
seeing that.
yeah,
And
yeah.
maybe dip a little finger in, and
Oh yeah, definitely.
you have to test the quality, don't you?
Yeah, yeah. Sometimes we get a big goldenrod flow and it tastes a little weird. Other times we harvest it in the summer and it tastes a little better. I guess I would come back and stress that deciphering the Tremble Dance was like a very special thing for me because my hero, Carl von Frisch, who deciphered the Waggle Dance, he once wrote, I think it tells the other bees nothing. I've never been able to figure out any meaning to it. And he observed it and described it back in the 1910s, 19 teens. And for 50 years, he wondered, why do some of the foragers that come back from his feeding station, why didn't they do it? Why do they do this trembling movement instead of a waggle dance? And it was frustrating to him. So I'm very proud of being the person that figured out what the tremble dance is. And it's basically a call. It's when a returning nectar collector comes in, can't find a bee that will receive her load of nectar, and so she does a tremble dance to call for more of the middle-aged bees to work as nectar receivers. I'm very proud of that. That's a special, shiny discovery in my mind.
That is really cool. There's so many ways they communicate.
Yeah,
I mean,
yeah,
dancing, trembling, pheromones.
shaking. Yeah, yeah, the mechanical ones like the tremble dancing, the waggle dancing, the shaking signals, the piping signals, all of those are we call those mechanical, and we can see them. We humans are really good at detecting those. It's the pheromone, the chemical side, that's all invisible. That's really hard. And I didn't go down that route at all because I knew, even though I studied chemistry, I was smart enough from what I knew of chemistry that stuff's hard. And so there's a lot of room there for the next generations to decipher the chemical signals.
All right. Last thing, Tom, would you like to impart some wisdom on us? Just any last thoughts that could help us be better beekeepers?
Yeah, I'd say it's like any craft. The more you know about it, the better you'll be in pursuing it. A lot of beekeepers are very bookish. It's fascinating. If you look at the number of books that have been written about bees and beekeeping compared to, say, the number of books written about other activities, fishing or things like that, it's like night and day. So I guess what I would suggest is just enjoy reading about the bees. There's a lot to learn about them, but there are many very good books about them. So that's what I would say.
On a personal note, I do have one last question. I can read all the books. I can talk to 100 other beekeepers. And as you know, I'm going to get 500 different answers.
Uh-huh.
Now, you're a scientist, so you're all about the books. Tell me if you agree with my philosophy at all, and that is that it's our job to learn as much as we can from as many different places, analyze the sources. There still is often not one clear-cut answer, and so we need some intuition. We need to be in tune in some way with our bees, sometimes to know what is going to be best for them, how we can best help them. Does a scientist agree with me on that one?
I do. Because, yeah, it's the difference between learning about beekeeping versus learning about the bee's biology. The bee's biology is what it is. It's either this or it's that. With beekeeping, every colony is different. Weather conditions change. The colony's strength changes. What's available for them to forage. That's a much harder one. And that's harder to communicate with the books. I'd say read the books, but also just work with an experienced beekeeper and keep good notes and study your colonies.
Dr. Tom Seeley, I appreciate you so much and all the work that you've done and how much I've learned from you over the years from your books and things. And what a pleasure to finally get to meet you and talk with you. And I hope we can do it again someday. Please keep in touch.
Thank you, Eric. And it's really been my pleasure. And I feel honored to be invited and share this information.
Thanks for joining us on Bee Love Beekeeping, presented by Man Lake. If you like this content, I hope you'll share it with a friend. follow and subscribe to this podcast, and even sign up for our newsletter at belovebeekeeping.com. Also, just a shout out to Vita Bee Health for their support. We appreciate them. Vita's Varroa control range of products includes Apistan, Apiguard, and now Varoxan, extended release oxalic acid strips. Thanks, guys. And remember, if you're not just in it for the honey or the money, you're in it for the love. See you next week.